Hey, you guys. In this section, we're going to be working with complex numbers. Okay. So expressions with I or imaginary numbers. So far, we've only done problems where our answers could be real. Okay. Now we are going to start experimenting with answers where our answers could include imaginary numbers, or we will see the imaginary unit I. Okay. So simplifying an expression like the square root of -9, all right, will not give us a real number. So we've seen that before in previous chapters. Before, if we ever got a problem like this, we just said our answer was not a real number. Okay. But now we're actually going to be able to answer problems like this. Okay. So we have to know what to do. So in this section, we can actually simplify similar expressions by expressing it using the letter I. And this is going to be called our imaginary unit. Okay. All right, so imaginary numbers. Okay. So this question, what solves the equation x squared equals -1? Okay. So before, in order to solve this, we would have taken the square root of both sides. X equals the square root of -1, and we would have stopped there. We would have said, well, you can't take the square root of a negative number. Now we are going to call this quantity, okay? We are going to say that's equal to I. So anytime we have the square root of -1, we're going to call it I. And anytime we have I squared, we're going to call it -1. Okay, so our powers of I, okay, are imaginary numbers. It says that the description is a number that can be expressed in the form of bi, where b is a real number and I is the imaginary unit. Okay,
and our powers of I are going to repeat. So I is always going to be equal to the square root of
-1. I squared is always going to be equal to -1. I cubed is going to be equal to -I, and I to the fourth is going to be equal to 1. Okay, so we're going to be using these in the problems that we solve. Okay, so like now, if we were to have a problem like the square root of -54, we can break that up into I times the square root of 9 times the square root of 6. We know that the square root of 9 is perfect, it's 3. And now this problem can be simplified as such. Okay, so we're going to practice working with imaginary numbers and complex numbers. So let's get to our first sets of examples. Okay, so this set says we're going to be simplifying imaginary numbers. So they want us to simplify these.
Okay, so when you start, I
notice that these are all square roots.
I know that they're square roots because the
indexes are 2.
There's no number
written there, but it's understood to be a 2.
Okay.
When you do this, you're going to separate these numbers into their negative parts and their positive parts. So that way the negative square roots we can simplify using the imaginary unit. Okay. So the square root of -36, I'm going to break that up into the square root of 1 times the square root of 36. So you see that I just pulled out the square root of -1 so that the negative part was separate from the positive part. And now I'm going to simplify. So we know from our previous definition that the square root of -1, okay, equals I. So anytime we see that, we can make that substitution. So this is going to become I square root of 36, okay? The square root of 36 breaks down. We know that that's 6. And I'm just going to write it so that my real number is in front of my imaginary unit. So that's going to be 6I. Okay? Let's try the second one. So I'm going to split the negative part from the positive part. Okay. The square root of -1 becomes I. And the square root of 20, we're going to remain. So the square root of 20, that's not a perfect square, so we're going to have to break it down. So if you guys remember, we broke down radicals using primes. Okay. So we can break down 20 as 2 times 10, 2 times 5. All right, because this is a square root, it means that our numbers can come out in pairs. So I have a pair of 2's here, and the 5 is going to have to stay behind. So that means my answer is going to be 2I square root of 5. Okay, so that 2 came out from that pairing, multiplied it by the I, and the square root of 5 stayed behind. Okay. All right, let's try the last one. So we have the square root of -1 times the square root of 7. Okay. The square root of negative 1 becomes I times the square root of 7. The square root of 7 doesn't break down, so we have to leave it the way that it is. And that's our final answer. Awesome.